Hello everyone. Today we are going to continue the KCET sequel of detailed question solving. Today we are taking up maths. I have the same D4 section. We are going to start with the maths questions. The first question is, if A is a matrix of order 3 into 3, then A square inverse is equal to. We know the formula. First one. A square inverse is equal to A inverse of square. How did we get this? We know the formula that inverse of AB is equals to B inverse A inverse. So similarly, we take A square is equals A square inverse is equal to A inverse into A inverse, which is equals to A inverse square. Second question. If A is equals to matrix 2 minus 1, 3 minus 2, then the inverse of the matrix A cube is. To find this, first we will find A square. A is equals to 2 minus 1, 3 minus 2. So A square is equals to 2, 3 minus 1 minus 2. We multiply. We know the formula how to find A square, right? So we'll use the same formula and row by column formula and we'll get 1, 0, 0, 1. So by using row by column method, we get A square is equals to 1, 0, 0, 1, which is also equal to I, that is identity matrix. Now we find A cube. A cube is A square, that is 1, 0, 0, 1 into A, that is 2 minus 1, 3 minus 2. We know that anything multiplied with identity matrix gives the same thing. So 2 minus 1, 3 minus 2. It becomes the same, that is A. This also becomes A cube becomes A. So we have to find A inverse, right? And we know that A square is identity matrix. So A into A is equals to I. So A inverse is equals to A. Since we know that this is equals to this from A square is equals to I, we get A inverse is equals to A. So that implies A cube inverse is equals to A, which becomes A inverse. We need to find A inverse, it will also become A. So the answer is A. Option D. A is the answer. Now third question. If A is a skew symmetric matrix, then A to the power 2021 is. This is a theory question. The answer is skew symmetric matrix. So the fourth one. If A is equals to 0, 1, 0, 0, then AI plus BA to the power n is where I is the identity matrix of order 2. For this question, we'd go hit and trial method. We go by hit and trial method since we have less time. But anyway, it will take a lot of time. So I would suggest don't go for this question. These type of questions, just leave it. Fourth one, A is equals to 0, 1, 0, 0. This is what we have, it is given. A is this. And then we have to find A into I plus B into A whole to the power n. We have to find this, right? Where I is the identity matrix, it's given to us of order 2. So let's take for n is equals to 1. We are putting n here. We are trying to do by hit and trial method. So we are using this. We are using the options to find the answer of n. What is the answer for this one? We are using options for that. Okay. So let's put option 1. So when we put n is equals to 1, P of 1 is equals to AI plus BA whole to the power 1 is equals to A into I plus B into A. Right. When we put power 1, it's the same thing. Okay. Next for n is equals to K. Any random power. Okay. So P of K is equals to A into I plus B into A whole to the power K, which is equal to a to the power k into I plus k a to the power k minus 1 b a. This is what we'll get. See, we have used the formula here. We have used the answer of first option. This is what we'll get. Okay. So now this we found it. Now for n is equals to k plus 1. Okay. So p of k plus 1 is equals to a into I plus b into a whole to the power k plus 1. We can write this as a into I plus b into a whole to the power k into a into I plus b into a. It's the same thing, right? A to the power m plus n is equals to a to the power m into a to the power n. So which is equal to a to the power k I plus k a to the power k minus 1 into b into a. The same thing that we found here, right? A to the power this thing to the power k. This is the thing, right? So that is what we have written here. Into, what is it? A to the power I plus b to the b into a. Right? So we multiply the whole thing. When we multiply both of it, we get a to the power k plus 1 into I plus k a to the power k b a to the power b a I plus a to the power k b I a plus k a to the power k minus 1 b square a square. Right? Which is equal to a to the power k plus 1 into I plus k plus 1 times a to the power k b a plus k a to the power k minus 1 b square a square. We take this as 1. Now a square is equals to, we are trying to find a square to substitute in the previous thing. Like here we did no. So here we want to substitute a square so that we'll get an answer for this thing. Okay. A square is equals to 0 1 0 0 into 0 1 0 0, which is equals to 0 0 0 0. So this becomes a null matrix. Okay. So what happens to the from 1 first equation, the equation that we had named as 1, this, what happens to this? This part becomes 0. It happens like a to the power I, a into I plus b into a whole to the power k plus 1 is equals to a to the power k plus 1 into I plus k into 1, k plus 1 into a to the power k b a plus 0. This whole thing becomes 0 because anything multiplied to a null matrix becomes 0. Okay. So after that we get, so from this is now equal to the previous thing, previously this one. So these all are now equal. So from this we get that option A is correct. Option A is correct. Okay. Option A is correct. This 1 minute question type, this is very lengthy, I would say. So just leave it as I said from the beginning. So next, fifth question. If A is a 3 into 3 matrix such that 5 into adjacent A, determinant of 5 into adjacent A is equals to 5. Then determinant A is equal to. Okay. So fifth one, 5 A is equals to 5. Right. We know that when a constant gets out of the determinant, it takes up. How did this become 5 cube? Because it is given that it's a 3 into 3 matrix. So when it is a 3 into 3 matrix, we use 3. When it comes out, it takes the power of n. That is, n is 3 here, 3 into 3 matrix. Okay. Now, as n is the order of the matrix, order of the matrix is given as 3 into 3. So we use 3. So we get 5 cube into adjacent A. So this becomes 125 of adjacent is equals to 5. So this becomes adjacent A, determinant of adjacent A is equals to 1 by 25. Right? So adjacent A is what? Adjacent A is determinant A to the power n minus 1. N is what? Order of the matrix. So this is 125. So this becomes determinant A by 3 minus 1, which is equals to 2. Okay? Becomes 1 by 25. So determinant A is equals to 1 by 5. Determinant of A. That is what we had to find. What is the determinant of A? That is plus minus 1 by 5. Remember that. Plus minus 1 by 5. It's given, right? Plus minus 1 by 5. Because we removed square, right? So it is plus minus 1 by 5. Next question. Sixth one. If there are two values of A, which makes determinant delta is equals to 86. So, and we have to also find the sum of these numbers. So we have to find two values of A and then add them to get the answer from these options. Okay. Sixth one, delta is given 1 minus 2, 5, 2A minus 1, 0, 4, 2A. Okay. So this is equal to, we know the formula to find a determinant, right? That is same row by column method. So we use the row by column method and we get 2A square plus 4 plus 2 into 4A plus 5 into 8, which is equal to 86. It is given in the question. It's given in the question, right? That the determinant is equal to 86. So 2A square plus 4 plus 8A plus 40 is equals to 86. Okay. If you have a problem in row by column method, you can comment in the comment box and I'll surely make a video on that as well. So going back to the question, 2A square plus 8A plus 44 is equals to 86. So we take 44 this side and we subtract it. 2A square plus 8A is equals to 42. We take 2 common, A square plus 4A is equals to 42. A square plus 4A is equals to 21. A square plus 4A minus 21 is equals to 0. We get a quadratic equation. We solve this. We get A square plus 7A minus 3A minus 21 is equals to 0. Okay. Here we take these two and then these two. We get A common, A plus 7 minus 3 common, A plus 7 is equals to 0. A plus 7 into A minus 3 is equals to 0. If you don't know how to solve a quadratic question, for that also I'll make a video. You can just comment in the comment box. So we get A is equals to minus 7 comma plus 3. Okay. And what do we have to find? We have to find the sum of these numbers. The sum of A. Right. So sum is equals to minus 7 plus 3, which is equal to minus 4. Minus 4, which is option D. Okay. Moving on to the next question. If the vertices of a triangle are minus 2, 6, 3, minus 6 and 1, 5, then the area of the triangle is. We know area of the triangle formula. 7th question. Area formula is area is equals to half of, put the vertices, that is minus 2, 6, 1, 3, minus 6, 1, 1, 5, 1. You know this formula, right? Determinant formula to find the triangle's area. I'm using that formula where you have to put all these vertices and then put 1 in the last column. Right? Now finding the determinant, we get, which is equals to minus 2 into minus 6 minus 5 minus 6 into 3 minus 1 plus 1 into 15 plus 6, which is equals to 22 minus 12 plus 21, which is equals to 31. So here we have written half, don't forget that. So area is equals to half into 31, which is equals to 15.5 square units. Remember, it's square units, not just units. So the answer is 15.5 square units. Okay. Now moving on to the next question, 8th one. Domain of cos inverse of x is where this denotes a greatest integer function. You know what a greatest integer function is, right? So let me draw the graph. We know that domain of cos inverse t, any variable t, is t belongs from minus 1 to 1, right? Close bracket minus 1 to 1. That implies GIF of x is it belongs to minus 1 to 1, right? So let's draw the graph now. Okay. Okay. Our this thing is between this. Okay. It is between minus 1 to 1. Okay. Our domain is between minus 1 to 1. So here we know the graph is 1. Okay. This is what the graph of a GIF looks like. That is greatest integer function. So here we know what all is inside and what all is outside. We get that from graph of GIF of x, x belongs. So we get that x belongs from minus 1 to 2 in a cos inverse function because 2 is open and 1 is closed. Minus 1 is closed. This is very important. If you do a mistake like this, then you will get different answers. Like see here. The options, as you can see, when it is both are closed, B option. When one is open, C option. When both are open, A option. When one is open, as you can see, you'll get confused like this. So you have to know perfectly which the answer is, or else you'll just make a grave mistake and come. The ninth question. If y is equals to 1 plus x square tan inverse x minus x, then dy by dx is. This is differentiation. So ninth one. If y is given 1 plus x square into tan inverse x minus x. You can cross check. This is the question. Now we have to find dy by dx. I am using the formula where f of x into g of x. When f of x and into g of x is differentiated, we keep f of x constant and differentiate g of x. G dash x plus keep differentiate f dash x and keep g of x constant. Okay. So same thing we are using here. So dy by dx is equals to, we keep this constant 1 plus x square and tan inverse x differentiation is 1 by 1 plus x square. Okay. this and this gets cancelled, plus we use this f dash x. So we differentiate this, we get 2x into tan inverse x. Okay, now we differentiate this. Don't forget this at the end then. Minus differentiation of x is 1. Okay, this got cancelled. We get 2x tan inverse x plus 1 minus 1. Here plus 1, here minus 1. These two gets cancelled. We get 2x tan inverse x as the answer. Option D. Okay. Now let's go to the next question, 10th one. If x is equals to e to the power theta sin theta, y is equals to e to the power theta cos theta, where theta is a parameter, then dy by dx at 1, 1 is equal to, here 1, 1 is the coordinates of x and y. Don't mistake it for theta. 10th one. Given x is e to the power theta sin theta, y is equals to e theta cos theta, and we have to find dy by dx. You know this, right? So we start, dx by d theta is equals to e theta. Sin theta will become cos theta. And e theta will differentiate e theta now. Same formula that we used above. We are using the same formula, that is keeping one constant, then differentiating the other one, then keeping the other one constant and differentiating the first one. Okay, so here we have kept e theta constant and differentiated sin theta, which is cos theta, and here we are differentiation e theta. Now differentiation of e theta is, that is e by e to the power x is e to the power x only. You know this, right? So e to the power theta is also the same thing. E to the power theta will also become e to the power theta into sin theta as it is, because this was constant now. Similarly, dy by d theta also will find, which is e to the power theta. Cos theta's differentiation is minus sin theta plus e theta. Differentiation is e theta into cos theta. Okay. We write dx by d theta as e to the power theta cos theta is also y. You see, we write it as y plus e theta sin theta. This is what? X. We write it as x plus y. Okay. And dy by d theta can also be written as minus sin e to the power theta sin theta is x. And this e theta cos theta is y. So y minus x. Okay. See, why did I do this? You might be thinking. Because when you just take these two together and find dy by dx, then you will have to find theta. And finding theta is impossible when x and y both are simultaneously 1. As it is given in the question that x, y both are 1. So how will you find only one formula where theta is 1? It is difficult. That's why we have to separate them as x and y. Okay. So then dy by dx will be equal to y minus x divided by y plus x. As we know, as we have to find dy by dx, when x and y both are 1, we get 1 minus 1 divided by 1 plus 1, which is equals to 0 by 2, which is equals to 0. 0 is the answer. Here as you can see, D. 0 is the answer. Okay. So now we have solved the first 10 questions of the maths paper. Next we will be solving the other 10 questions in the next part, that is part 2. Stay tuned for the next part. I hope you understood everything, and thank you for watching. If you liked it and want the part 2, make sure to like, share and subscribe the channel for more updates.